grab that. Okay, we'll have a quick 5 minutes. So you can go and grab a drink, use the facilities. Sorry for the warning here. Get the fresh air. Literally just 5 minutes, so I'll start chatting and we'll start back in the seats for my life. Thanks everyone. Okay, so great first talk. Thanks very much to Mike Miell for that. Thanks to you all for putting your name badges on, especially you, Mr. Fluffy. Hey. Okay, right, so let's move on and let's talk about Kubernetes. Is anybody here using Kubernetes? Sorry, that wasn't obvious. Sorry, no, put your hands down, put your hands down. I was just going to say, there is a Kubernetes meetup on right now at Kono. So I'm not sure how many people will have with that sort of skill set. But if you're not using Kubernetes, then here's the man who knows all about it. So Mr. Miell is going to talk to you about testing Kubernetes clusters, so please do what you can. Thank you.
Thank you very much. So can you hear me all right? Yep. Is that, yeah? Okay. So I'm going to talk tonight about kind of a journey I've been on for the last 18 months of persisting with the attempt to test Kubernetes clusters in the face of losing my sanity and lots of other challenges along the way. So my name's Miell. I've written a couple of books, Docker in Practice, Learn Git, and Learn Bash the hard way. I also do bits of training, a lot of training in Git at the moment. I'm also writing a book called Terraform, and I have a blog that may be of interest to some people here. So before I start, who here is using Terraform? Not Terraform, sorry. Actually, who here is using Terraform? Quite a few. Okay, interesting. Who here is using Kubernetes? And about a quarter of the room, I think. And who here is using it in production? Okay, I have a question for you people. How do you test your upgrades and maintenance and so on? Yeah, watch it break and then fix it fast, right? So yeah, I'm going to talk a little bit about that. Who here is using Chef as a configuration management tool? Oh, good lord, what is going on? Okay, who here is using Puppet as a... Ansible? Very popular. Salt? What happened to Salt? It was huge like 3 years ago. It's all I'd ever heard about. Now I don't hear anything about it. Anyway, so the sort of summary of the talk is that the company I work for, well, me and some colleagues, the company I work for is a blue bank based in Canary Wharf. And we created our own way of testing Kubernetes clusters that we believe is fast, accurate, cheap, reliable, and it was mainly because there seemed to be no way to do this that we knew of. So, the problem. I put this tweet on a while ago and got a nice response, and it was after a particularly bad day at work. So, the company I work for, we run multiple Kubernetes clusters in production, non-production, and pilot, in multiple locations, and with not enough. I mean, no one has enough staff, but we really don't have enough staff. And it's a real challenge to keep all the balls in the air. We have all sorts of challenges which I'll go into later. But the solution that we ended up building, I've also used to build Chef environments, IPsec tunnel POCs, Nomad clusters, OpenShift and pure Kubernetes clusters. And I take requests on... Does anyone here run any sort of cluster other than Kubernetes or any sort of containerized thing? What do you run that's clustered?
Rancher.
Rancher?
Okay.
It's
horrible.
Ceph?
It's horrible, okay. Ceph clusters, okay. And is there like a standard way you test them?
That's the open source product for you.
Okay, yeah, so you rely on it being okay. Yeah. So technically we don't run Kubernetes clusters, we run OpenShift clusters. And if you don't know what OpenShift is, you can go to openshift.com and find out. Essentially, it's a Red Hat's application platform as a service. It's essentially, it takes Kubernetes and it packages it in a way, in an opinionated way, such that you can consume it relatively easy. You lose all the headaches of worrying about which overlay you want to use. All these things that Red Hat kind of do for you, sommelier for you, and you can also pay for support and so on. If you want to, there's an open source version, it's upstream, it's called Origin, and that's what we use to test our work, because we do our testing outside the corporate network. So what is it on top of Kubernetes? Well, it's lots of things. It was RBAC, role-based access control, which is now in Kubernetes. It's been molded into upstream Kubernetes. It contains a registry, and therefore the lifecycle you can build push containers internally within the cluster, which you can't do with Kubernetes out of the box. It contains a router, and you get support services, public registry, image management, all the sort of standard enterprise stuff. And as I say, at my job, we have multiple clusters in various states, and what we want to be able to do is to make a change to our configuration management code and trust that it's going to work when we give it to our run team. Okay, so how do we deploy OpenShift? Well, the standard Red Hat solution for deploying OpenShift is to use Ansible. And we don't, we use Chef. And it's not an uncontroversial decision. We used Chef because one main reason was that it's a strategic configuration management for our organization. So if you want to go off-piste and use your own, you've got a couple of challenges. One is getting it through governance, and the other is having the potential for configuration management fighting going on. So you run your Ansible code, and then Chef comes in and clobbers what you did. And that's the sort of thing that's harder to solve when you've got two different CMs going on.
Server or solo?
Sorry?
Server or solo?
We test with solo and server, but we run server in production. We have, essentially Chef gives you root, if you run Chef. So the fact that it's centrally managed and centrally got through governance means that using Chef is a free pass. And Chef is also, and this wasn't one of the reasons we used it, but it happens to be, in effect, in practice, it's much faster for us to deploy and test because deployment goes on in parallel. So I help maintain, along with Will back there. Will, raise your hand. Say hello to everyone. I help maintain where are we? Community cookbook. No? Yes, this one. On GitHub, which is based on Origin. So it tests, it deploys and manages Origin. And there's a few other organizations like us who don't necessarily want to make themselves known, who use Chef to deploy OpenShift as well. So let's get there we go. So if you're building a Chef community cookbook to deploy OpenShift, the question arises: how do you test changes? Will is the principal maintainer of this code base, and he's really quick at testing this stuff by hand. However, it's difficult to scale that. So if you have lots of different configurations, potentially lots of different configuration items and so on, as time goes on, it's harder and harder to rely on one coder doing a great job to make sure it works everywhere. So we needed a solution that was automated, cheap, easy to edit, and programmable. We also needed to test multiple versions of the product because we're enterprise. We were 4 when I started this talk, writing this talk. Now we're 6 releases behind the mainstream. We need to test multiple versions of dependencies. So there's lots of dependencies when you run a thing like this, and you need to make sure the work against those. and multiple configurations, and needs to be fast so we can run all the above within a reasonable time. So what the options, I scouted around and asked people, like I did just then, how do people do this? I asked testers. The best answer I got was use Kitchen. Kitchen's great, but it's single node only, and doesn't reflect how you deploy a real cluster. So when we deploy our Chef cluster, we set up a certificate server. Certificate server sets up an HTTP server, which then serves certificates on demand to the client nodes. Can't really simulate this in Kitchen. You can do a single node and you can sort of simulate it, but it's not going to reflect the real world. We could have used Ansible, but it's slow. We don't use it in Corp, so there'd have been that sort of impedance mismatch there. Could have used AWS. It's quite costly. Vagrant can be very painful to use. Asked at work, asked on GitHub. I raised a ticket with Kitchen. And basically they said, no, someone might do this someday, but we can't do it, it's too hard. So the solution we came up with was to use an automation tool of my own devising called Shut It. And hello. There we go. So essentially, I did end up using Vagrant. It wasn't fun, but it now works, but it wasn't easy. So you have an automation script to create the base Vagrant box. So this is for caching. So rather than take a CentOS image and deploy everything every time, I put the core stuff that doesn't change very much into a cached box. That cached box is used as the basis for another shutting script, which spins up multiple machines in various configurations. So the most complex configuration, you've got 3 essentially D nodes, 2 masters, several nodes, certificate server, chef server, and a chef workstation. And once those are provisioned by chef in parallel, the chef recipes run solo or server, and they download certs from the cert server, get all set up, install everything, check that they're ready to go, run the app tests, and then destroy the VMs. So it's an entirely reproducible process. Okay, so what technologies did we use for this? So we used VirtualBox. I use VirtualBox because it's free and I'm not really a Red Hat person at home. LibVirt we can also use. We use Vagrant for virtual machine management. Has anyone used LandRush and Vagrant together? So LandRush is a fantastic technology which allows you to provision machines, Vagrant machines, and gives them DNS access between each other and from the host. So it makes it a very realistic environment to play with clusters on. And obviously we use Chef. And there are also kitchen tests within our repository as well. We also use pexpect. Has anyone ever written an expect script? And was it fun?
No.
So pexpect is a Python pip install which does everything that expect does, more or less. And Shut It is essentially a layer on top of that to make it easier to run. I'll try, if I have time, I'll do a quick demo at the end. We also use, I've put Robocop, it's actually Rubocop. We use Rubocop and Food Critic, and we use Jenkins, and what else do we use? Yeah, that's it. And the effect of all this is to shift things very much to the left. Has anyone heard the expression shift left? Very trendy term these days, especially in the enterprise. So the idea is that you fail earlier. That's basically what it does. So Rubocop, it checks for bad chef, doesn't it? And Food Critic is your own policy about your chef, what you personally like and don't like. So in order to get this to work, it had to overcome a lot of issues, and it was really very, very painful. And there didn't seem to be standardized solutions to this out there. So one was managing the DNS on my host and within VMs. So there were bugs in LandRush which have been mostly ironed out over time. Interfaces, in Vagrant, interfaces can be very unpredictable in terms of how they show up. Chef makes assumptions about what networking interfaces there'll be on your machine, and I had to code around all sorts of weird cases that I came across. I had cached the base image in the Git repo itself to save build time. That was fun. Outdated stuff. Oh yeah, so yeah, then you can forget that your software has become outdated in that base image, and we had an issue last week with that that we built. I even hit LandRush running out of IP, so the subnet was 256, 254 IPs, and actually used them all up. So it just went through them serially, and then it just went to 0, 0, 0, 0. So I hit that bug. IP address updated directly in Chef code. I had to write a patch to a Ruby file in Chef to avoid that problem. Swap space on Vagrant. Weird failure cases on Kubernetes application startups. I had to handle the different states that applications could end up in. That was fun. Race conditions in the terminal itself with pexpect, which happened so rarely. I had to run tests for 36 hours to trigger them again, but I eventually got around those. Obscure bugs in Kubernetes setup, which Ansible does not see because it's serial. So because Chef runs in parallel, we were occasionally hitting race conditions where the master doesn't start up properly because it thinks that Central D is available. And I went onto the Ansible, I went onto the OpenShift forums, and they said, well, this never happens to us, so it must be something you've done. But actually, it's a problem with Kubernetes itself. Many more have suppressed the memory of. For example, today we discovered that the SE Linux policy cookbook, which we happen to depend on, changed the call to set SE bool to implicitly use the path and not an absolute path, which caused Chef triggered from a cron to fail. That was a fun one to figure out today. So, lessons learned. Only change one thing at a time, if you can. The problem is that if a full test can take like 3 hours to run, and so code can change faster than that, so it can be hard to keep up. Kubernetes is really complicated, and I listed some of the challenges we've got there. I'm going to read or run out, but it's really, really fun to deal with all of those. So, was it worth it? Has anyone seen this cartoon before? No? Yes? No? It's an XKCD cartoon, which is can be quite a handy reference if you want to know where to automate a task. So this is how much time you shave off each time you run it. And this is how often you do the task. This is how much time it's worth investing to automate. And the thing every time I try and automate something, I think it's only going to take a day, and it ends up taking 18 months. Or I spend, it's really, really hard. But I guess the thing that's really, the investment has paid off, but it's been very, very hard to keep going. But over time, it's paid off more and more. So the benefits are the usual testing benefits. So we can move faster. We can have more confidence in changes. We can refactor. We've been refactoring a lot. So Will's been refactoring the code 3 or 4 times in the last week, and then just trusting that the tests will find stuff. And also bugs that you have can be fixed while the recent changes are still in your working memory. That's a huge win. The costs have been not insignificant. It's been a lot of effort to build this framework and deal with all the seemingly irrelevant side issues / yak shaving / time spent dealing with all this stuff. However, the tooling behind it has improved a lot as a result. And so I've used it. I've used the same sort of framework to build other kinds of clusters. And so the value is not always clear, and it can be very hard to justify to your colleagues where you're spending your time. But over time, because when you invest in this thing, the benefits are reaped cumulatively. It's easy to justify. Now I think it's very hard to imagine a life without these. Whereas I think building it now from scratch will be very, very difficult to sell. So another thing we learned is pick your battles. So you saw there were a lot of machines, VMs involved. And if you've got 9 VMs, you could have 1 VM up to 9 VMs. That's 9 factorial possible combinations of machines you could test. And you have different bugs with those, so you cannot test all of them. And then you've got configs, so you've got loads of different configs, you've got different storage configurations, you've got different kernels, different versions of Docker, so on. We have a quick canary test, which takes about 40 minutes, and then we have a full suite, which can take about 24 hours. And the full suite doesn't even cover all the cases we could have. So you have to decide where you're going to invest your test time. So this might be interesting, given the last talk. Why not just use the cloud, right? I thought about it, and I looked at Scaleway, which is the cheapest provider I could find. And there's costs both to using the cloud and not using the cloud. So, as is often pointed out, having a server at home needs you to set it up, needs you to maintain it, and you've got electricity costs, you've got costs of managing it, and so on. However, if I run this on the cloud, there would probably be other costs, such as the extra cost of setting up the VMs each time. The actual cost of it is, as you can see, about twice as much as it would be the raw cost. I don't particularly mind the cost of setup. I like having the spare compute capacity at home. I actually use it for lots of different things. So for me, I'm not saying it works for a large organization, but for me it's much cheaper. I also like the fact that I get an asset that has a value rather than just spending money. It's my money as well. It's not. I don't charge this back to my employer. So yeah, it's a very hot topic for me. Yeah. Also, a few supposedly bare metal providers I tried didn't allow virtualization, and I tried a few and then asked a few help desks and didn't get much of a response, so I kind of gave up on that. And as I say, it didn't work out cheaper, so I haven't really pursued it. I guess one thing about the cloud is that it's much more scalable. So in theory, I could run hundreds of tests simultaneously. However, I found that if I run more than 2 or 3 tests at a time, I forget why I did the test in the first place. So I'm looking at my Jenkins output and going, yeah, it's failed. Now why did I run this test again? So yeah, for a one-man band, I think working at buying a server and having it at home is better for me anyway. Okay. Have we got time to just do a quick demo? So I'm going to try and do a quick demo of creating a cluster, a simple cluster. So you see that, okay? Yeah. So if I do shut it skeleton. So this is the tool I wrote, shut it, and it allows me to create automation tools in various contexts. So it asks me for a path, and then it gives me the option of do I want Bash shell script, do I want Docker, do I want Vagrant, do I want a Docker-based tutorial environment, or do I want a shuttle file? We won't go into what they all mean, but let's just choose Vagrant. Okay, how many machines do we want? I'm going to stick to 2. What do we want to call the machines? Anyone?
Alice and Bob.
Alice and Bob, okay. Do we want Docker machine? Yes and no? No. you want to snapshot the machine. I've got options to snapshot and push to, I've got my own Nexus server at home, so I push boxes for completion. So I'm happy with that. Go Ubuntu Xenial, and it downloads a bunch of libraries for me, and gives you some instructions. So I go into shut it relies, and this is the script that will create the cluster of 2, and it will call them, what do we call it, Alice and Bob? So we've got Alice and Bob 1 and Alice and Bob 2. So if I scroll down to the end, we've got this login bit. So here it will log me into the servers. Do Alice and Bob 1. And then, oops, so I can do something like this. And so on the first one, I can do touch. And then go on to the second server and do that. Install Apache 2. And then if I do some nonsense here, which will fail, and then run it, it goes off and builds the 2 VMs on my host, gives it some DNS. It runs those commands that I gave it. And then if all's well, it finishes with an Xcode of 0. If it fails at any point, and if we left it for 10 minutes, it would eventually get there, it'll deposit me in a shell in the place where an error happened and allow me to continue if I want to. So it's using Brew. Who here uses Brew? If you use the debug functionality, it's fantastic. So you install something in Brew and something doesn't compile, you use debug and it drops you into a shell and says, hey, this thing didn't work. And you can choose to ignore it, you can raise a ticket, or you can just you can ignore it, carry on, fix it and carry on, or do whatever you like. Yeah, it's a really powerful tool. Anyways, similar to that, it does it in that way. So, okay. So that's how I would use it to create a cluster. So it's fully automated, runs on my laptop, it's fully reproducible. Okay, so if anyone's interested in this problem, has this problem, would like to solve this problem, I'm always looking for help. Particularly use cases. So if people have like a cluster that they maintain and are not sure about how to upgrade or safely upgrade it or want to test it, I'm interested in talking to you about use cases, how you solve that. Anyone who uses libvirt, I'm interested in talking to heavily. It's be nice to get that side of it working reliably. And any terminal or shell gurus who know about race conditions in terminals, great. Any old sort of green screen users of like the actual terminals around? Oh, a couple of hands. So if you want to find out more, ask me, tweet me, or email me. Thank you.
Okay, just time for a couple of questions if anyone has one or two. Anyone? Sean's always got a question. So I'll come to you second. Sorry. Do you have a question? Yeah.
Just quickly, congratulations on a very sophisticated test environment. But I guess on a score of like 1 to 10, how confident are you that the infrastructure that you're testing is a really good reflection of the infrastructure that you're deploying to in production?
That's always a
challenge. There's some differences.
Yeah.
It's so sophisticated.
So there are definitely, I mean, one difference, for example, is I use CentOS VMs on my Vega cluster. The real one is RHEL. The CentOS one uses standard Yum repos. The one at work uses different ones. In an ideal world, I'd run all this on the enormous infrastructure we have at work available to us, but for various reasons that's not feasible. Mostly due to the difficulty of getting any software into an organisation like that. Provisioning hardware is hard, which is partly why I wanted to use Vagrant, just so that I could buy a big server at home and forget about it. The idea is not to reduce the uncertainty to zero, it's to reduce the uncertainty to as small a window as you can manage in a practical way and a cost-effective way. We do have a set of Terraform and a bunch of other automation within the organisation running in a development environment. That also is slightly different to, it doesn't use this stuff, but that is also slightly different to production. So before it gets to production, it'll go through this test, it'll go through a test in our development environment using Terraform, etc., and then it will go to a pilot environment, and then to a non-production environment, and then finally to production. So the idea is that in each stage you'll learn the slight edge cases that you find. But more confident than we would otherwise be.
Okay, cool. Sean, you're standing between all these lovely people and some pizza, so make it brief.
I will attempt to make it brief. I've been around the houses a bit with Kubernetes testing, automation and stuff. So my only question really is, are you doing PKI in testing?
Are we doing what, sorry?
Are you doing PKI in testing? Are you doing PKI in production? And how are you doing it? Like, generally, what are you using?
We use the standard OpenShift tooling for that. So it's not a company-wide, in terms of the cluster, it's not a company-wide PKI, it's just the CA is generated on a certificate server, and then keys are, certs are created off that.
You're using Chef for that? Okay, that's cool.
Cool. Ian, thank you very much.